My name's Luke Smith. I'm managing director at a company called Build Test Solutions. We manufacture a product that can be used for measuring air tightness. So we know this market inside out. So I thought today we'll cover a quick intro into what air tightness is exactly. Apologies if teaching you to suck eggs on this one, but we're going to go right back to basics. What is air tightness? Why is it important? How do you relate air tightness and ventilation? They are two distinctly separate things, so we'll cover a bit on that. And then, as much as it might be perceived as a requirement in regulations, another cost, another thing to have to do, there are actually an enormous number of opportunities in relation to air tightness. So we're kind of go and unpack those. And then we'll look at the technology options. Like I said, we're a manufacturer of one. I'll disclose the others available, and we can talk openly about the respective merits of the various technologies. And then we're just going to close with just a few tips on procuring for air tightness and thinking about integration of air tightness testing in your projects, and some key things to consider. Okay, so what is air tightness exactly? So it's all about seeking to eliminate unintended air movement into and out of a building. It's often referred to as infiltration. It's just as much, and so that would imply ingress of external air. It's just as much as the egress of air as well. So it's that two-way exchange of air in a building that isn't strictly intended to be there. So we're talking about poorly fitting windows, failed draft stripping, service penetrations, gaps and cracks in the building, tongue and groove failing in the suspended floors and letting air permeate through the suspended floor structures, gaps in plasterboard, just general unintended leakage. And as I alluded to there, it could be down to the inherent construction of the building. So appreciate the emphasis here is residential retrofit, but if you think about a light industrial unit, actually you'll if you've got bare exposed breeze block walls or concrete blocks, they in themselves can be permeable, and so it's not uncommon to see bare concrete blocks painted or a light kind of plaster skim on them to seal them and serve as an air barrier. It can, of course, also be down to poor workmanship. So, putting service pipes through with a hammer rather than a specifically sized drill bit and grommet and what have you. It could be down to poorly fitting sort of junctions and sort of edges and interfacing of materials. For instance, you can have lovely fancy new windows, a lovely new external wall insulation render system, but actually if you're not thinking about how you align those windows with that insulation system, you could risk kind of having all of these trims and expanding foam and sealant around the edge that frankly isn't giving you that all important airtight seal. And of course you just have air leakage down to general degradation of the building fabric. So invariably over time, rubber window seals are going to degrade, crack, split, dry out, and cause air leakage. Loft hatches are going to warp and become poorly fitting. All of these things are invariably with time, settlement, gaps and cracks. It's not uncommon for sort of the air leakage paths to kind of creep their way in over time and through general degradation. And it's a really important thing. So uncontrolled air leakage can account for as much as a third of total heat loss. That would be a really extreme case. That's quite a lot of leakage, but typically in that range of 10 to 30%. And so even if you do the fanciest fabric insulation program, floor insulation, wall insulation, loft top-ups, if you don't pay attention to air tightness, you risk actually bypassing all of that very expensive insulation. And so, if you ventilated cavities, for instance, air leakage being able to go up the cavity, sort of through plug socket, through service penetrations, up the cavity, out the wall plate at the top, it's completely negated external wall insulation that you might have applied potentially. So it's a really important proportion of your overall heat loss. You may well apply insulation, reduce that thermal transfer through the fabric itself, but if air can move around and bypass it, then that's not what we want. So of course, improving air tightness reduces heat loss, reduces the associated running costs. You're not heating air up that then readily escapes, and it creates a more comfortable living environment for the residents. So yeah, just to really kind of hammer those points home, air tightness is good for energy efficiency, reducing heat loss in the winter. It really is low cost, true hanging fruit. If we're thinking here, replacing, upgrading window seals, replacing loft hatch seals, really kind of paying close attention to service penetrations, any really obvious air leakage paths. You can do a lot of those things very cost effectively and be addressing that kind of 10-30% of your total heat loss. It's really important for comfort. So again, thinking about that example of doing a really deep retrofit of lots of fabric interventions, even if you've left your resident with a much better insulated home, an occupant is still going to be very, very sensitive to air movement. That kind of classic feeling of sat in your living room and you feel a draft. You don't quite know where it's coming from, but there's air movement from somewhere, and there's a temperature difference between your toes and your head, and it's even though you've got all of this insulation, air movement is still a cause of discomfort, and that will be down to air leakage or the sort of air movement bypassing the insulation somewhere. It's a really good very interesting when you think about building durability as well. So if you've got air leakage paths through the fabric, you risk obviously warm, moisture-laden air from within the home, from cooking and bathing, passing through the fabric, but potentially condensing on cold surfaces halfway through the leakage path. So for instance, at joist ends or on the inner face of a cavity wall. So you don't want that kind of high humidity, high humid air really passing through leakage paths and condensing within the building fabric. It's not going to do the building structure any good. But it's it's also just a general good indicator of sort of quality of workmanship to test, measure air tightness before and after a retrofit. You're spending thousands of pounds on insulation. You would like to think that the measurement would highlight the insulation's been installed well, and there's been lots of due consideration to air tightness, and sort of the devil's in the detail when it comes to delivering the intended outcomes from retrofit programs. So being able to measure it before and after is really important there. And then air tightness is not strictly going to have a direct influence on indoor air quality as such. It's not the act of making a property more airtight isn't going to make the air cleaner or reduce the sort of generation of pollutants within a home or outside a home, but it is going to give you much better overall control. So if you, for instance, properties near busy roads, there's a lot of external air pollutants. By being more airtight, you can then actively manage the ventilation strategy, making sure that you're pre-filtering incoming air or delivering sufficient air changes to make sure that kind of pollutants aren't lingering in a property. And similarly from inside out, if you think about moisture generation from bathing, cooking, like we were just saying, you don't want that to linger in a property and be able to pass aimlessly through leakage paths. You want to be able to have really effective extract ventilation that's pulling that moisture laden air out through the intended route, the continuous running fan or whatever it may be. The illustration there is just to give you an idea of kind of common leakage paths. I've referenced a few as we go, but your loft hatch, your service penetrations, poorly fitting windows and doors, window seals, your flue service penetration, your wastewater pipes. A really common one is your cold feed supply and return to your header tank in a loft if you've still got system boilers. But bypassing behind plasterboard in new builds is another common one. But they're all fairly common, relatively obvious kind of points that you could sort of target and make sure that you're addressing on your projects. Okay, so I made lots of cross-reference already to ventilation. So just in terms of elaborating a bit more on the relationship between air tightness and ventilation, I'm sure many of you will fully appreciate the importance of ventilation and why it's needed. But essentially what we've got in the situation we have at the moment is that the majority of existing homes in the UK rely heavily on infiltration as the primary source of ventilation. We've got these, frankly, pretty shitty intermittent extract fans in our wet rooms that wouldn't be unusual to be whirring backwards with a bit of a wind against them, or clogged up with dust and not actually delivering much in the way of extraction, or they're very noisy and ineffective. And so aside from that kind of minor intermittent kind of extract provided by the fans, your air changes are almost entirely delivered by the inherent leakiness of the building. And that sort of works to a point, but you start adding insulation measures and tightening down on the property, making it more airtight, then you start to tip the balance, especially when you've got higher levels of occupancy, or occupancy behaviours that are generating higher levels of moisture around, frankly, normal occupancy behaviours, bathing, cooking, that kind of thing. But yeah, you really start to put stress on that ventilation strategy, i.e. you can no longer rely entirely on a bit of background infiltration, which is only going to work if it's windy or there's a decent temperature difference between inside and out to really drive the air changes. It's definitely, you hear a lot of talk about our old building, Victorian, Edwardian, Georgian properties. They were designed to breathe. We can't be sealing them up. I think people get really confused. Actually, with breathability is something more to do with the management of vapor and moisture transfer through construction materials. Buildings don't have lungs, they don't breathe per se. It's absolutely correct that we should be chasing the utmost levels of airtightness. We should be trying to make our buildings as airtight as possible in the interest of energy efficiency and eliminating any uncontrolled air leakage. There is nothing wrong, regardless of building type or construction or age or conservation status. We should be pursuing buildings to be as airtight as possible, but then we need to be complementing that with a suitable ventilation strategy. So continuous extract being the most obvious sort of solution that's readily retrofittable. But yeah, you could go more advanced with your kind of MVHR, with sort of mechanical ventilation with heat recovery, continuous supply, and extract in a full ducted system or what have you. But yeah, chasing air tightness is the right thing to be doing, but making sure that we complement that with adequate ventilation. I've got personal experience of this. My own property, I did a deep retrofit, took air tightness from an air permeability of 15 at 50 pascals all the way down to 2 at 50 pascals. And actually, I only had intermittent extract fans in the bathrooms, or bathroom, I should say, and trickle vents in bedroom windows. And my wife and I, we were waking up with headaches. It's not that you can go so airtight that the building's hermetically sealed and no one can breathe, but if you're not delivering sufficient air changes, you're not expelling CO2, you're not expelling moisture. So we were having condensation issues, headaches in the mornings in the bedrooms from inadequate ventilation. So it's great that we had such levels of air tightness, but we did then need to upgrade the ventilation system to a continuous extract solution, and it completely cleared up all the condensation issues that we had, and the air quality drastically improved. So that's a really good example of go really far with air tightness, but actually not doing the ventilation in tandem. So yeah, we've touched on infiltration, and as a primary form of ventilation is inefficient, unreliable, especially with modern living habits. We need to be pursuing purpose-provided, controllable ventilation. We can't just rely on wind and stack effects and temperature difference to give us the ventilation we need in our homes. Mechanical extract systems work most effectively when installed in a more airtight home, so you don't have these issues of potential shortcutting. So, for instance, if you've got a really expensive continuous extract fan in your bathroom, if there's a massive air leakage path in that same bathroom, all it will be doing is drawing air from outside through that leakage path, through the bathroom fan back out. It'll be delivering some air exchange in your bathroom, but it won't be reliably drawing on the rest of the house through door undercuts and bedrooms and so on. So yeah, air tightness again really helps make sure that the ventilation system works effectively. And that ventilation is, of course, needed to reliably extract the buildup of moisture and air pollutants in the interest of occupant health and building health. So you arrive at this really important mantra that I'm sure many of you have heard before: build tight, ventilate right. Or the other one is no insulation without ventilation. But yeah, the two go hand in glove. And we'll come back onto air tightness very shortly, but this is why air tightness testing is so important, is because unless you know how airtight the building is, you can't possibly be expected to devise a ventilation strategy that you know is going to be appropriate for the situation at hand. I'm not here to talk at length about ventilation systems per se, but just to give you a snapshot as has been touched on already. These slides will be made available after the event as well. But a really common, readily retrofittable solution for ventilation is mechanical extract. So this could be centralized, a single unit in the loft space, for instance, ducted to your wet rooms, and just having a single exhaust point, just continually running, extracting from the property. Or what's known as DMEV, decentralized mechanical extract, which would be wet room based, continuous running fans straight through the wall and straight out, so no need for any ducting, and they're just running in the background quite reliably. Or of course, the Rolls Royce would be kind of mechanical ventilation with heat recovery. So you've actually got both an inlet and an outlet in the loft space, or from an airing cupboard or similar to outside, and you're passing that incoming air over a heat exchanger and filters, preconditioning incoming air to living spaces and bedrooms, and then having the extract serving your wet rooms again. And that just adds a degree of efficiency, so you're no longer dumping heated conditioned air straight to outside. You're preconditioning it and offering this supply air to other spaces in the home. But frankly, as great a system as it is very difficult to retrofit, as many will appreciate. Running supply and extract ducts to upstairs and downstairs isn't always very practical. Okay, so getting on to the nub of this then, so air tightness testing, the requirements and the opportunities. First, I wanted to say, as much as this is about retrofit, all new developments in the UK require an air tightness test as part of Part L, L1A and L2A for non-domestic buildings. And that's been the case since 2007. So there is a very well-established industry of air tightness testers in this country that have predominantly served the new build compliance market. And then in recent times, we've had obviously PAS 2035, 2019, and now 2023. And this is requiring that every property has an air tightness and air leakage testing strategy. So the relevant clauses there is 8.2.35 and 8.2.36. I've got another slide on that to unpack that in a bit more detail, because I appreciate that creates a bit of greyness. What's a testing strategy? It doesn't say to explicitly test exactly, but we'll come back onto that. Then within Part F, this was updated in 2022. And there's some sections in there that make reference to the importance of understanding the air permeability in order to inform the most appropriate ventilation system type. So that's section 1.45 and 1.46. And so there's a relationship between air tightness and what would be the most appropriate ventilation system, all very clearly set out in Part F. And then section 3.7, the bit about existing homes in Part F, talks about, again, making informed judgment about the ventilation based on expert advice and air permeability testing. So again, Part F is guidance. It's not explicitly saying thou shalt air tightness test on every project, but again, it's making that important link between air tightness and ventilation in the ventilation regulations and guidance. And then many of you will be familiar with this as well already, but RDSAP 10 went live earlier this week and permits the input of air tightness test results into an EPC. You've also able to do this with full SAP and SBEM for non-domestic buildings. So that's a really interesting development that, again, we see as being something that's going to help drive or start helping to provide a clearer case for doing air tightness testing. And I've got another slide on that in a moment. And then we also see air tightness tests being used as part of MCS 12831 heat loss calculations for the purposes of improving the precision of those calculations for the purposes of heat pump sizing. So you've got a choice of, you could just guess what the air tightness is and plug that into your model, or measure it, better calibrate the model, get much more representative kind of insight into what the true heat loss is likely to be. And then air permeability testing comes up in the same sentence often as the concept of background ventilation testing. So this is probably not for today necessarily, I'm conscious of time, but it's a means, or it's another form of testing that can serve as a means of satisfying Annex C of PAS 2035. So understanding how leaky the existing property is to inform or help make a better judgment on the need for additional, or going further with your door undercuts and adding additional background passive ventilation into bedrooms. I recognise that there's a lot of confusion in the market at the moment around, okay, PAS is requiring me under this first clause, 8.2.35, to have an air testing strategy. But what does that mean exactly? What does a good strategy look like? Here, I would defer principally to Part F, where there is, under Section 3 of Part F, what's known as a simplified method, which considers whether an intervention is minor or major in relation to likely to impact the air tightness and ventilation. And I think if under the simplified method, you're dealing with retrofit projects that are category B or C, i.e. more kind of on the major side of the fabric interventions, a sensible strategy from a pure risk management perspective would be to test everything pre and post, 100% sample testing. Now, I do appreciate that's a big undertaking, but I think it then goes hand in glove with the EPC benefits of doing that testing and being able to plug those numbers into your EPCs and realize the SAT point benefits. So then as a cost per SAT point gain, the EPC uplift, it starts to make a lot of sense. So for the cost of an air tightness test at, let's say, £150, £200 a property, if you can gain 1 or 2 SAT points just by overriding that otherwise default air tightness value, that cost per test is actually very cost effective, kind of bang for your buck on the grand scheme of things. So you're not only satisfying PAS and have a robust air tightness, air leakage strategy, you're getting some EPC uplift benefit out of it as well. And then there's, people don't pay much attention to this, but Section 13 of PAS talks about there needing to be monitoring and evaluation going on projects. So again, air tightness testing pre and post ticks a big box there. And then, like I've touched on, you've got Annex C, encouraging projects to think about the relationship between air tightness and the provision of adequate ventilation. So as much as PAS doesn't say thou shalt test, when you start to think about this in the round and a sensible risk-based approach, you quickly come back to, actually it makes a lot of sense to be testing. So yeah, RDSAT 10 now permits the input of measured air tightness values. Typical default values, if you would otherwise suggest, use the lookup tables, you're typically assuming the air permeability to be in the order of 10 to 50 pascals. On the chart on the right here, we've got a sample of 35,000 pulse tests, all unique individual existing properties. There's no new build in here. And the mean air permeability is 8.3 at 50 pascals. And you can see there a really wide distribution. So it's not unusual to see some out at 15 air permeability or higher, but equally we're encountering a good number that are 2 to 4, 4 to 6 air permeability at 50. So a lot of existing buildings are actually more airtight than you might think. And it's that classic, you can't manage what you don't measure. And so until you've actually tested and understood what you've got, how can you possibly conceive a sensible ventilation strategy? And if you imagine even simply hitting that mean value of 8.3 rather than using the default air permeability value of 15, just turning up at a property and doing that more robust, more accurate assessment and plugging that number in your retrofit assessments or EPCs, you're going to get we estimate between 1 to 3 sat point benefit without even making any interventions. You haven't improved air tightness, you haven't changed anything at the property, you've just overridden a conservative value with a measured value. Let alone then you go on and do internal wall insulation, suspended floor insulation, and so on. And again, doing the air tightness test post works, you would see an even greater uplift there, I think. To be plugging these numbers into RDSAP, you need to be a level 1 qualified tester and registered with a competent person scheme. So that's one of my tips later. You've got to make sure that you're using suitably qualified and registered professionals. And testing needs to be done in accordance with CIPSE TM23, which is basically the approved procedure referenced by Part L for new build. So it makes a lot of sense that we're testing existing homes in the same way that we do in new build homes. And all of the above applies to your MCS 12831 heat loss calculations as well. So if you're putting a lot of effort into assessing the suitability, viability of heat pumps in homes, why wouldn't you do an air tightness test to make sure that the calculation is as accurate as it can be to give you the best possible steer on what size heat pump you might need? It wouldn't be unusual to see a heat loss calculation done entirely with assumptions telling you might need a 10 kilowatt peak heat pump, and then to plug in an air tightness test and that shift to an 8 kilowatt peak system, or dare I say even a 6 kilowatt peak system. And there you're talking about thousands of pounds worth of capital cost savings and the lifetime operational efficiency of the heat pump being improved. Again, I appreciate bloody hell, 200 quid per property on a pre, and then again on a post test air tightness, it's another cost, but it's in the interest of improved longer term decision making and capital investment targeting. So that's my second sort of headline message: is better calibrate models with measured inputs. Okay, so just in terms of your technology options for measuring air tightness, basically two main solutions. You've got Pulse, which is a compressed air based system, release a burst of air into a building and measures the pressure response to return an air leakage result at 4 pascals. We're seeing this quite heavily adopted in retrofit. It's very simple to operate. It's non-invasive, so you're placing the equipment centrally on the ground floor. It's that short, sharp burst of air. Yeah, you're typically in and out of a property well within kind of 20 minutes or so. The blower door fan has been around a bit longer. It's been heavily used in new build compliance testing. This is the act of mounting a fan within the doorway of a home. And depending on which way around you orientate the fan, you're either pressurizing or depressurizing the property and taking a series of readings to determine the leakiness. And a fan is typically operating across kind of 30 to 60 Pascal pressure range, referencing the results at 50 Pascals. So I like to describe the blower door fan as it's a great stress test of a building, sort of pushing and pulling on a building fabric to measure how leaky it is. And it's really good for leaving the fan in place and doing your leakage diagnostics. But you are compromising that front door whilst you've mounted the equipment, and you're either sucking heat out of a property during winter or blowing a gale into the home to do the test. You'll hear different stories, but typically a blower door test, you're in the kind of 20 to 50 minutes range. Truthfully, price point wise, we don't see much of a difference in the marketplace. I think it's going to depend mostly on how many properties you can put forward on a scheme. So there's a lot of cost associated with someone travelling and gaining access to plots. So the more you can put forward in the same estate or street, the more efficiently they can be delivered. And then it's all about access, and it becomes a bit more of a numbers game in terms of sort of scales of economy and that kind of thing. But yeah, as one-offs, typically you're looking at that sort of £100 to £250 per property per test. A few complementary activities to air tightness testing. With the blower door fan, you can do your diagnostics. There are also standalone products you can buy for doing sort of basically mini fans that can be mounted in a window to do diagnostics as a standalone exercise. So that can be great for site teams and contractors to be kind of measuring and chasing leakage points whilst the retrofit takes place. With a depressurization on the building, you could then use a thermal imaging camera and start to visualize, particularly in winter, that kind of passage of cold air, maybe behind plasterboards or behind, in ceiling voids and that kind of thing that wouldn't otherwise be visible. Equally, using a smoke pen or just the back of a hand, you can feel that air movement with adequate depressurization on the building. And then, given the link up between air tightness and ventilation, it also makes a lot of sense to, if you're commissioning someone to be there to do a retrofit assessment or an EPC, they're adding the air tightness test. It's also prudent to measure the ventilation extract rates. How is that fan that you've currently got installed performing in the home? Is it in line with what the specification says it should be doing? That's always worth checking. Ordinarily, surveys are just visually, yeah, there's a fan there, yeah, I can see it's spinning away, but you don't really know if it's delivering the extract rates that you need until you measure it. Final slide then, just a few closing tips on procuring air tightness. So I think it's really important to prescribe the test protocol that you expect an air tightness tester to follow. As much as PAS 2035 doesn't stipulate in outright terms the exact procedure to follow, I think it makes a lot of sense to reference CIBSE TM23. Just it's a third-party independent test specification that it will just ensure consistency in terms of how testing's being carried out. And even if I was prescribing CIBSE TM23, I would still go so far as explaining what the expected building preparation shall be. So all internal doors open, external windows and doors closed and latched, purpose-provided ventilation closed or temporarily sealed where an operating mechanism doesn't exist. So if trickle vents can be closed, if a chimney damper can be closed, just close it and leave it as is. If your through-the-wall extract fan doesn't have a damper on it or won't close, you should temporarily seal that off. So then consistently across all of your testing that you're commissioning that the air tightness results are comparable between properties and buildings have all been prepared in the same way, the same test procedure has been followed. Touched on it earlier, you want to be using competent persons, so require that testing is carried out by a level 1 qualified air tightness tester who are a member of either Elmhurst or the ATMA air tightness testing competent person schemes. You may or may not deem independence to be important to you, so is the contractor doing the work the one also doing the testing, or is it something you want to get independent contractors to be doing? I know there's a real mixed bag out there in terms of delivery of people. It's not unusual for a contractor to deliver the PAS 2035 compliance alongside the project delivery, but the delivery of works. But again, you might want to consider if independence is important to you, and indeed the scope to bring air tightness testing in-house perhaps, to test your own properties. Reporting wise, you don't just want a number. I think you want to be asking for a copy of both the test certificate as lodged through the competent person scheme, but also a test report for each property. So show us the detail of the measured envelope area, volume, all the technical parameters of the test, all the observations taken on the day of the test, as well as the test result, ideally expressed as air permeability, but also air changes per hour, as equivalent leakage area. So you've got basically all the richness of information that you deserve for the money you've paid. Probably some eyebrows raised when I mentioned kind of 100% sample testing under PAS as part of your air tightness strategy, but honestly, I think sample test at your peril. No two buildings are ever the same. You wouldn't otherwise just sample your retrofit assessments or EPCs. You can see here this chart, air tightness measurements directly track EPC ratings, so it's a really good barometer of the overall energy efficiency of a property. I really don't think it's something to be skimped and saved on. And then test type, be really clear. Is it air permeability testing that you want in line with CIBSE TM23, or is it background ventilation testing that you want in line with basically that this is a separate scheme hosted by the IAA, the Installation Assurance Authority, to support installers in providing a pragmatic means of satisfying Annex C of PAS around assessing the need for undercuts and trickle vents and so forth. So that they're very similar but subtly slightly different things. And yeah, it would be particularly cost effective actually to do both in one sitting. But yeah, be really clear about what test type you're actually asking for. Thank you very much. I will stop there.